Hey Math 1 students, we are going to look at one variable inequalities today. Some of this will be review from middle school and some of it might be some new stuff for you. The first thing we need to know if we're going to talk about an inequality symbol is that we're essentially dealing with something very similar to an equation, but we don't use an equal sign. There are 4 different symbols we're going to use for inequalities. The first one is the less than symbol. So I'm going to highlight the parts that if you are copying on paper, I would really suggest writing down. You maybe don't need all the words, so I'll give you the important parts. The way that I remember the less than symbol, and this might help you as well, is that it kind of looks like an L, like a squished L, but it looks like a capital L. And that might be the same way you learn left from right. So if you hold that up, the less than symbol, left and less both start with L, they look like L's when they're open. When we add the little line under the symbol, we call that less than or equal to. The greater than symbol goes the other way. And then same thing when we add the line under it, that would be greater than or equal to. When we work with solving inequalities, we actually use the same strategies we used with equations. Same ideas, things like distributing, combine like terms, isolate the variable. All of that part stays the same. There are a couple of new things that we have to think about. One thing is that if you multiply or divide on both sides using a negative number, we have to flip the inequality sign. So if we divide everything by -2, in the last step, we have to change the less than sign to a greater than sign. And we'll see at least a couple examples of that. Another thing, this one is not necessarily required, but it is helpful. If you end up with the variable on the right side, I would suggest flipping the whole answer. So if you end up with something, for example, like 5 is greater than x, that's just kind of a confusing way to write that. It's a lot more clear when the variable's on the left. So if we want to flip that, we can reverse the sides. We can switch the x and the 5, but we would also need to reverse the sign to hold the statement's truth. So we can write 5 is greater than x, or we can write x is less than 5, which is just sometimes a little bit less confusing conceptually. One thing we'll do is look at our answers with number lines as well. So I want you to think about equations. When we were solving equations, most of the time we got one answer, like x is 5, exactly. However, in like the example I was just doing before, if I said x is less than 5, there's a lot of numbers that x could be. It could be 4, 3, 2, -1. It could be any number less than 5. And so we represent that on a number line. So this part I would copy down. And I'm going to put a box around it. You may want to pause and take a second to copy this down. When we have the less than symbol, we use an open circle. So when I say open circle, I mean a circle that is not colored in, and our arrow should go to the left. Now do notice this, the direction that we're telling you to shade only works if the variable is on the left, like we suggested. The open and closed circle will be true no matter what. We, for greater than, would use an open circle and shade to the right, so draw our number line or our arrow to the right. When we have the equal to piece, so when we add the line under it, notice the circle gets colored in. And the reason that is if I say x has to be less than or equal to 5, it's allowed to be exactly 5, and we represent that with a colored in circle. If it was just x is less than 5, I could have 4.999, which is very close to 5, but not 5, and we represent that with an open circle. So let's jump right in with some examples. I'm going to zoom way in so I have enough space to write. Here's our first problem. I'll give you a chance to write it down. It says 3, parentheses, 2x plus 5 is less than or equal to 39. So, like we said before, the strategies we're going to use are the same. I would still personally suggest drawing the line down your paper just to keep you organized. There we go. So, first thing I would probably do here is distribute. So, I would take that 3 and multiply to everything in the parentheses. 3 times 2x is 6x. And 3 times 5 is 15. And that's still less than or equal to 39. And now we're down to that two-step concept. This time it's an inequality, but same idea. So I would subtract 15 on both sides. which will leave us with just 6x on the left is less than or equal to 39 minus 15 would be 24. And then final step, divide by 6. And now notice I am dividing, but I'm dividing by a positive number, so I do not have to flip my sign. 24 divided by 6 is 4. So we were also asked to represent that on a number line. So I'm going to draw myself a number line, and this does not need to be a work of art. And I like to put usually just 3 numbers. Sometimes a number line might be provided for you, but when you're drawing your own, I'll show you what I do. I draw my number line, and I'm going to label just the value. I'm going to start by labeling just the value that I was interested in for my answer. So my answer was x is less than or equal to 4. So in the middle of my number line, I'm going to put a 4. I also, just to make sure I really understand what I'm representing here, I'm also going to put a number to the left and the right. So 1 to the left would be 3. We're moving down the number line as we go to the left. And then up we would do, the next number up would be 5. So now we decide open circle or closed circle, and this one should be a closed circle at the number 4. And it's closed because we had that equal to part in our answer. It said x is less than or equal to 4. Less than, numbers less than 4 would be going to the left, so I'm going to draw an arrow to the left. And what that represents is all of my possible answers for this inequality. Anything that is less than or equal to 4 would be my answers. Right. So this problem is mostly similar to the last one if you're wanting to try it. There is one little catch, so I would probably stay with me on this one. I'm going to draw my line. We've got 4 parentheses negative x plus 9 is greater than 16. So same as the last problem. I like to get rid of parentheses, so I'm going to distribute. 4 times negative x would be negative 4x. And 4 times 9 would be 36 is greater than 16. Now we're down to that 2-step part, so minus 36 on both sides. That will leave us just with the negative 4x is greater than 16 minus 36 is negative 20. And now I have to divide everything by negative 4 to get x by itself, but notice I am dividing by a negative. So because I divide by a negative, I have to reverse my inequality sign. So now it was originally a greater than, I had to reverse it to be a less than. And negative 20 divided by negative 4 is positive 5. And that would be my answer, which again we can represent on a number line. So my answer here is x is less than 5. To represent that visually on our number line, I'm going to sketch my number line. And I like to just put a couple. You can put more numbers if you want. I just usually put 3. So I'm going to list my 5 in the middle. And then 1 up and 1 down, so 4 and 6. Now for this problem, I'm going to have an open circle at 5. I have an open circle at 5 because there's no equal to piece under my symbol. And it's less than again, so again we're going to be going to the left. So any number to the left of 5 is part of my solution. All right, let's try number 3. So number 3 is going to follow, again, very similar things. I think you could definitely start this one on your own if you want to pause and try it. So I would still distribute first. So all of this will stay the same. 2 times 4x is 8x. And 2 times negative 7 is negative 14. trying to get the x by itself, so I can move things away from the side with the x. So I'm going to add 14 on both sides. 2 plus 14 is 16. It's greater than or equal to 8x. And now to get that x by itself, we divide by 8, which gives me 2 is greater than or equal to x. And now, that's fine, that's correct, but we usually like to see the x on the left just because it makes a little bit more sense to us. So if I reverse it, I'm going to write it as x is less than or equal to 2. I'm allowed to switch sides as long as I also switch the sign. So now let's do our number line. Pause right here and try this number line by yourself. All right, so on my number line, I would put a 2. 1 less would be 1. 1 more would be 3. So this one, we should have a closed circle because it said the equal to part, and it's another less. So we're going to be going to the left again. All right, we've got 3 more problems for you. This one is going to be very similar. We're going to have an extra step here to combine like terms. Feel free to pause and give this one a try. So if I were doing this, I would want to distribute first. So I'm going to multiply that 5 to everything in parentheses, which will be 5x plus 35 minus 7x is less than negative 9. Now, to clean things up a little bit, I notice I have a 5x and a negative 7x that could be combined. 5x minus 7x would be negative 2x plus 35 is less than negative 9. Now see if you can finish this problem out. Pause and then turn it back on when you're ready to check. I'm going to subtract 35 on both sides, which gives us negative 2x is less than negative 9 minus 35, which is negative 44. And then finally I would divide by negative 2. Which gives me x, and I have to flip my sign because I divided by negative, is now greater than negative 44 divided by negative 2 would be 22. So I'm going to graph that on my number line. This is the first one we've seen that was a greater than in our answer. So on my number line, I'm going to put 22 in the middle. 21 would be 1 less. 23 would be 1 more. I'm going to have an open circle at 22 because my symbol does not have the equal to line under it. It's just greater than. And for greater than, we will go to the right. For example, 23 is that direction. It is greater than 22. All right, number 5, very similar to the last one. Feel free to try it. So I would probably start by distributing. We've got 50 is less than or equal to 2 times 3x is 6x. 2 times negative 10 is negative 20 plus 4x. And just like the last example, I can combine like terms. So on the right side, I have a 6x and a 4x. 6x plus 4x makes 10x. Now we're down to 2-step, so I can add 20 on both sides. I get 70 is less than or equal to 10x. Finally divide by 10. we get 7 is less than or equal to x. And so that answer's fine, but it typically helps us out if we'll reverse that order to put the x on the left. And if I switch their sides, I have to switch the direction of the sign. So I'm going to write my answer as x is greater than or equal to 7. On my number line, I'm going to put the 7 in the middle, and a 6 and an 8. And I just like to put those numbers just to help me understand what I'm saying, which way I should be shading, to help me to think a little bit more logically. So I've got a closed circle at 7. We want greater than. So that will go to the right. For example, 8 is greater than 7. All right, last problem. I would suggest giving this one a try. See how you do. We've got, very similar to the last one actually. We're going to start by distributing. So I'm going to take that 3, multiply it by everything in the parentheses. So that'd be 3 times 4x is 12x. 3 times negative 7 is negative 21 minus 15x. Combine like terms to clean up a little bit. So 12x and negative 15x. 12x minus 15x would be negative 3x. And now we're down to our two-step. I can add 21 on both sides. 9 plus 21 is 30. Divide by negative 3. That would be negative 10. And because I divided by a negative, I've got to reverse that inequality sign. So I get negative 10 is less than or equal to x. Again, I like to write it with the x on the left. So I'm going to reverse the sides, which means I have to reverse the sign as well. So I can say negative 10 is less than or equal to x, or I can say x is greater than or equal to negative 10, and that I think is a little bit easier to understand. So this is where I think number line becomes most important when you're dealing with negative numbers, because negative 10 goes right here. Remember that negative numbers kind of move backwards from our positive numbers. They still we go one less when we go to the left, which would be at negative 11, and then at negative 9, but it looks backwards from the positive numbers because it is, as we move through negative numbers, we're moving away from 0 in the negative direction. So I'm going to fill in with a closed circle at negative 10, and I want greater than. Right, so thank you for watching. We'll get some more practice with inequalities in class.